Okay, so next what we're going to do is we're going to look at the next kind of situation with solving these equations. So this is a situation where you can have an infinite number of solutions. And so you might be thinking, well, how does that work? Well, hopefully this video will explain that to you. So let's look at our example. So example here, we're going to do our distributive property. I'm not going to go quite as slow as I normally do just because that's not the purpose of this video. 3 times 6 is 18, and then 3 times negative 4x would give me negative 12x. And then over here, I'm going to wind up with negative 2 times 6x gives me negative 12x. And then negative 2 times negative 9 gives me positive 18. Now, just stop and look at this for a second, all right? So I'm just going to try to highlight something here. These are my variables. And then these are my constants. So what do you notice? Do you notice that they're the same on each side? Hopefully you do, because they are. So you've got negative 12x and negative 12x. So there and there, those are the same. And then you've got 18 and 18. Well, those are the same too. So the problem this presents with us, and you're going to see this in a second, so when we start trying to combine things, something weird is going to happen. So let's just go ahead so you can see what happens. So it doesn't matter on this one which side we pick to put the variable on. So let's try to put the variable over on, let's move it over to this side. All right, so let's add 12x. So I'm adding 12x. And when I do that, this is when you start to realize strange things are happening. It cancels here, right? And so you're thinking, oh, well, what's he talking about? This is fine. You got 18 on this side. And then what happens here is it also cancels on this side. So suddenly you have an equation where you have no variable. And then you're left with this. Well, I don't know if you remember seeing this before, but whenever you have one side completely equal the other side, this is called an identity, all right? And what an identity means, if you get an identity when you're doing one of these problems, what it means is that no matter what number you pick, it will make this equation work. So let's oh yeah, really? All right, let's try 0. So let's put 0 in and see what happens. So if I go 3, I got 6 minus 4 times 0 on this side. And then you got negative 2 times 6 times 0 on that side, minus 9. So what you get over here is, well, 4 times, sorry, I'm having a hard time reading this. 4 times 0, this cancels out and that cancels out. So you get 3 times 6, right? Gives you 18. And then you get negative 2 times negative 9, which is 18. Okay, well, it worked out that time, but let's try another number. So let's try 2. All right, and we'll do this one in orange. So 3, and we'll do it right over here. 3 times 6 minus, well, 4 times 2 is 8, right? Equals negative 2 times, well, 6 times 2 is 12, minus 9. Sorry, that was really bizarre. So I'm going to put that right here. I apologize. So 6 minus 8 is negative 2 times 3 gives me negative 6. And then over here you have negative 2 times, well, 12 minus 9 is 3. And that gives me negative 6. So the moral of the story is no matter what you do with this, you can put any number in to this for x and you are going to get the same answer. So the way we describe how to write this down is this is called infinite, so never-ending solutions, right? Infinite number of solutions, all right? Infinite solutions, all right? And later on you'll learn to say all real numbers, all right? But you can just call it infinite solutions for now. And that's what this is all a case of, is no matter what happens, everything will work.